Whoa! I never thought about that!
Today, we are going to completely uncover the fascinating living system that miraculously transforms a simple flat ball of dough into that perfect fluffy pizza crust we all crave. We're going to look at the very real science happening right there on your kitchen counter, breaking down exactly how everyday pantry staples come together to create something absolutely spectacular. Because let's be honest, we all love a good slice of pizza, right? But have you ever actually stopped to wonder how the exact same everyday ingredients can create such wildly different textures? I mean, you go to one pizzeria and the crust is incredibly airy, light, and just full of these beautiful bubbles. But then you go to another place, or maybe try making it at home, and it turns out super heavy, firm, and dense. The ingredients are basically identical. So what is the secret? Well, the secret isn't a fancy technique. The secret is actually alive. Which brings us to part 1, meet the microscopic hero. Okay, so the secret ingredient to an airy crust isn't some rare spice or a magical baking powder. It is quite literally a living thing. Yeast is a microscopic fungus. Now I know, the word fungus might sound a little weird when we're talking about your dinner, but this tiny organism plays a massive, fundamental role in baking. It completely transforms our simple dough from a static, lifeless pile of flour and water into a breathing, highly active scientific system. And humanity has actually relied on this organism for a remarkably long time. Ancient civilizations utilized bread and fermentation incredibly early in human history, long before microscopes were even a thing. They just knew that if they treated their dough a certain way, it worked. It actually wasn't until much later, in the 1850s, that the famous scientist Louis Pasteur finally pulled back the curtain. He was the one who discovered that yeast wasn't just some chemical ingredient, but a living creature that actively causes fermentation. Moving right along to part 2, the science of rising. So how does it actually work? Well, there's a brilliantly simple 3-step process at play here. When you add yeast to your dough, you are essentially feeding it. Step 1, our tiny living hero eats the sugar that's present in the dough. Step 2, as a byproduct of this microscopic feast, the yeast produces carbon dioxide gas, or CO2, along with a tiny amount of alcohol. Finally, step 3, because the yeast is just constantly eating and producing all this gas, the carbon dioxide builds up and the dough is physically forced to expand. If you want a perfectly clear visual for what's happening on a microscopic level, just think of blowing air into a balloon. When you force more and more air into a rubber balloon, it has absolutely nowhere to go, right? So the balloon stretches and gets bigger. That is exactly the same mechanic the yeast is executing inside your dough. The carbon dioxide gas acts as the air, and your dough is the balloon, expanding as that gas gets trapped inside. Now let's look at part 3, building the gluten network. This brings us to a very important player, gluten. Flour naturally contains proteins. When you mix that flour with water and you begin to physically work or knead the dough, those proteins bind together to form gluten. You can think of gluten as a stretchy network that acts like a highly elastic and super durable mesh woven right throughout your pizza dough. The absolute crucial point here is that this stretchy gluten network has to be strong enough to trap the yeast's gas bubbles. Without gluten, the carbon dioxide produced by our yeast would just escape straight up into the air, leaving you with, well, a flat, hard cracker. The gluten network grabs onto those bubbles, and that is precisely what creates the incredible, soft, airy internal structure of the crust that we all know and love. Which leads us to part 4, the heat of the oven. Sliding the pizza into a blazing hot oven triggers a rapid chain reaction. Step 1. The extreme heat causes all that trapped carbon dioxide gas to rapidly expand, giving your pizza one final beautiful lift. Step 2, the environment simply becomes way too hot. Our hardworking yeast inevitably dies from the extreme high temperature, its job finally complete. And then step 3, the outside of the dough quickly sets into place, forming that firm crust. This literally locks in the shape and the airy texture we've spent all that time carefully building up. Finally, let's dive into part 5, crafting the perfect crust. The coolest part is that manipulating simple physical variables completely changes your final outcome. If you look at fermentation time, a short rest gives you a dense dough, while a long rest gives the yeast time to make an airy, deeply flavorful dough. Now, what about water content? Using more water makes the dough softer and airier, while less water makes it firm and dense. And kneading, the more you knead it, the stronger that stretchy gluten network becomes. Less kneading leaves you with a weaker structure. It's a really delicate, fascinating balancing act. You also have to carefully balance your temperature and your flavor ingredients. Temperature acts as the main throttle for your yeast. A warm temperature means the yeast works much faster, puffing up the dough quickly. A cold temperature means slower fermentation, but it actually results in a much better flavor. Meanwhile, the ingredients play a huge biological role too. Sugar is essentially fuel. It feeds the yeast. Salt, on the other hand, keeps the yeast in check, controlling its activity so it doesn't just go completely wild on you. And here is a super fun fact that all the great pizzerias know. Warm fermentation gets the job done quickly with a pretty standard flavor, but utilizing a cold fermentation, like simply putting your dough in the fridge overnight, is the ultimate pro move. By purposefully slowing the yeast down with a cold environment, it takes a lot longer to rise, but it yields vastly superior flavor and an incredible texture. That's exactly why the absolute best pizza places take their time. It is truly amazing to realize that your pizza isn't just a simple mix of pantry items. You are literally combining a living fungus with a few basic ingredients to engineer a dynamic breathing system of science in action. So, armed with this delicious knowledge of how yeast works, from eating sugar to building a giant gluten balloon, all the way to facing the fires of the oven, I leave you to ponder this. How will you master these variables the next time you crave a perfect slice? Keep exploring the science behind the things you love, and we'll catch you in the next explainer.
And that's just one tiny big question. Imagine what's next. Subscribe, and let's keep wondering.